Welcome, CP Finite Mathematics, to Unit 3. In this unit, we're all talking about matrices. Okay, so new terms, some new things to look through, and today it really shouldn't be too challenging. So first off, what is a matrix? A matrix is defined as a rectangular array of the form, okay, so in general, they can be all different sizes. So maybe here's one. And for example, we have something like this is going to be a sub 1, and then a sub 2, and a sub 3, a sub 4. It could be something like that. And then you have another row we'll refer to as, and c sub 1, c sub 2, c sub 3, c sub 4. Now, it could go on in either direction. What we refer to in the matrix here, so each of the little parts we refer to as an element or a cell, okay? And basically, again, they could be any certain sizes. So you could have another one with numbers in here. So like 1, 2, 3, 4, 5, 6. Negatives are allowed. It could even be like 1, 3, all sorts of different sizes. So the dimensions, it is important to know what dimensions we're looking at of a matrix. The dimensions are the size of the matrix, and it's always rows by columns, okay? So this first matrix with the A's and B's, there are 3 rows. Rows go across, and columns go up and down, okay? So this would be a 3 by 4 matrix. The second one, this would just simply be a 3 by 2, and this would be a 1 by 2 matrix. A square matrix, we're going to do some work with those in the future, basically has the same number of rows and columns. So for example, down below here, we're going to be using these matrices. A would be a 2 by 2 matrix, and that's what we would refer to as a square matrix. So we're going to operate with some of these here. B is a 2 by 3. It does help to write these dimensions down. We have another 2 by 2, and we have another 2 by 3. Okay, addition. Matrices must be the same dimensions in order to add or subtract. And it's really pretty simple. So if we want to add matrix A and C, A is 2, 1, 3, 4, and we want to add that to the other matrix, 1, negative 2, 2, and 7, pretty simple. You're just going to add the corresponding elements. So 2 and 1, hey, that's 3. Oh my gosh, this mathematics is crazy. 1 plus negative 2 is negative 1. 3 plus 2 is going to be 5. And 4 plus 7 is 11. Hard mathematics there. A plus D. So notice A is a 2 by 2 and D is a 2 by 3, and that is not possible. So I would like you to specify when things aren't possible and why they're not the same dimensions. So notice that D is a 2 by 3. You have extra elements that cannot be added to A. Subtraction, really, again, same idea. Now they must be the same dimension, once again, and you can subtract corresponding elements. So if we want to take D minus C, okay, D is negative 3, 6, and 2, and then 2, 4, negative 8. And if we want to subtract matrix C, let's do 1, negative 2, 2, and 7. If we look at that right away here, well, they are different dimensions, so it is not possible. So curveball there. D minus C, that's the same example. Let's do one that is possible. So let's see. If I need it to be possible, they have to be the same dimensions. So we're going to change this to B. And just to show you subtraction here, negative 3, 6, 2, 2, 4, negative 8, and subtracting b, 1, negative 2, and 4, and negative 1, 0, 2, and you're just going to subtract each element. So negative 3 minus 1, so that's actually negative 4. 6 minus negative 2 is going to be positive 4, actually going to be 8 minus a negative, so be careful with that stuff. 2 minus 4 is negative 2. 2 minus negative 1, once again, is going to be 3. Subtracting a negative makes it positive. 4 minus 0 is just 4. And run out of colors here. Negative 8 minus 2 is going to be negative 10. So be careful with the minus and negative. You could distribute the negative and change all the signs, and then change to addition, whichever way really you prefer. Scalar multiplication. There's two different types of multiplication. We're just going to do scalar today. And basically, that's just going to make a small matrix, kind of like you're scaling a picture, and you're just going to make it bigger. So 5 times A, that's pretty simple. If we have 5 in the A matrix, 2, 1, 3, 4, it's the good old distribution property 4 times. So you're just going to multiply that 5. So 10, 5, 15, 20, and you're scaled, and it's ready to go. We will be combining some of these matrices here, some of these operations, just like regular old mathematics, okay? So 2 times matrix C is 1, negative 2, 2, and 7, minus 3 times matrix A, 2, 1, 3, 4. You want to approach it just like you would an old school math problem. I would distribute everything first. So 2, negative 4, 4, and 14. And we'll be subtracting that from 6, negative 9, actually negative 6, and I'm going to change it to addition as well. So I'll distribute the negative and change to addition. Negative 3 and negative 12. And then, since I already distributed the negative, I can just add them. So negative 4 plus negative 3 is negative 7. 4 plus negative 9 is negative 5. And 14 plus negative 12 is 2. So a few different options. You don't have to distribute the negative. I chose to do that here. But again, hopefully it's pretty simple stuff starting out here. The most challenging aspect of this particular lesson is solving for missing parts of a matrix. So corresponding matrices are corresponding and equal as long as each element equals its counterpart. So an example would be a matrix like 2, 1, 4, 2. Okay, that's going to be equal to, well, 2, 1, 4, 2. Okay, each element equals its counterpart. Top left, top right, and so forth. To find missing variables, to make the matrices equal, it's just a mix of solving. So we have 2 variables we need to solve for, x and z. And so these are the same size matrix. Don't be confused because you have z plus 2 up there. But basically what we have is that in this first cell of each, we have the equation 5 equals z plus 2. In the bottom cell, we have 2x equals 8. And then we have 2 little mini equations to solve. Aren't they cute? And subtract 2, and we have 3 equals z. And divide by 2, we have x equals 4. So some pretty simple stuff here, but just getting you used to matrices. One that's a little more challenging, so let's find x and y. We have a little bigger matrices. It is important to notice kind of how they're broken up. So I like to draw little dashes in there just to kind of help me recognize things. Right off the bat, we could see, hey, 4 and 4, those are good to go. The 3y minus 4 and the 26, those must be equal. So I'm just going to set up my little mini equation. Down below, x plus 7 and 11, those must be equal. And then in the last cells, 8 and 8, those are already good to go. So little mini equations, pretty harmless. 30 equals 3y, so y is equal to 10. And subtract 7, x equals 4. Bada bing, bada boom. Okay, 2 more examples, a little more challenging, but I'm confident you can all do it. Now, though, we're going to utilize some other skills. So x minus 2y and negative 20. That is going to be one equation that we're going to have to set up. Okay, it's a good idea to check the other cells that are already numbers, make sure they're equal as well. Negative 2 and negative 2. And what do we got here? We have 4 and x plus y. Well, chapter 2, we solve systems of equations. So guess what's back? We can set up a system of equations from these two and solve that. Now, you can use any method you'd like. Later in this chapter, we're going to reveal the matrix method to solve these. It's going to blow your minds. But you should be comfortable using substitution or elimination. I'm going to use elimination. I'm going to multiply everything by a negative in the bottom. So remember, the x's would cancel. I would have negative 3y is equal to negative 24 divided by negative 3 means y is 8. Don't forget, we got to substitute it back in. So I'll choose x plus y equals 4. 4 equals x plus 8. So I'm just using this. And then pretty simple, x equals negative 4. So a little bit of combining what we did in the past to that there. Last example is just you might have to do some operations first in order to yield that equivalent matrix. So we're going to focus on this side here. And it's going to be a little tricky to notice here. So remember, addition, same cells add together. So 2 and 4 is 6. Now, the next cell is going to be a little interesting. It's y plus 3. And you're literally just going to write that in that whole cell. So this is all one cell. X plus 2, same idea. And 5 plus negative 5 is 0. Okay, so now we can see a little more clearly what we need to make equal to one another. 6's are good, the 0's are good, so we have y plus 3 equals 13, and we have x plus 2 equals negative 8. Some pretty easy equations. Y is 10, and x is negative 10. Boom, 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 boom. So welcome to The Matrix. All right. If you haven't seen those movies, there's a new one coming out soon. Go check that out. But good stuff, guys. Hopefully lesson 1's pretty easy. Try out the practice problems. These are attached as well. I don't think there's any curveballs. Please do state the reason why you can't add if that is the case. Okay? And yeah, good luck. Check your answers to that stuff. And have a good day, guys.